In this section, I'm going to teach you how to insert, update, and delete data. Before we get started, let's have a closer look at our customers table. So click on this middle icon to open this table in the design mode. What you see here might look a little bit intimidating at first, but trust me, this is actually so easy. And in this tutorial, I'm going to explain exactly what we have in these columns. So on the left side, you can see the column name. Next to that, you can see the data type for each column. So our customer ID column can only accept integer values. Integers are whole numbers like 1, 2, 3, 4, and so on. They don't have decimal points. First name is a varchar, which is short for variable character. Now here in parentheses, you can see 50. That basically means in this column, we can have a maximum of 50 characters. Now, if the name of a customer is only 5 characters long, we only store those 5 characters. So even though the maximum length for this column is 50, we are not going to waste space if the customer's name is less than 50 characters. That is why here we have varchar, which is short for variable. In contrast, we have another data type that is character. If we had character 50 here, and the name of the customer was only 5 characters long, MySQL would insert additional 45 spaces to fill this column. So this is a waste of space. So as a best practice, most of the time we use varchar to store string or textual values. Now here on the right side, we have this column PK, which is short for primary key. So customer ID is marked as the primary key, and that is why we have this yellow key here. So the values in this column uniquely identify each customer. Next to that, we have NN, which is short for not null, and that determines if this column can accept null values or not. In this case, every customer record must have the customer ID, first name, last name, as well as these other attributes. But birth date and phone are optional. So in these columns, we can have null values. Now we have another column here, AI, which is short for auto increment. And this is often used with primary key columns. So every time we insert a new record in this table, we let MySQL or our database engine insert a value in this column. So essentially, it gets the customer ID for the last row, and it will increment it by 1 at the time we insert a new record. So if you look at the data, you can see that currently we have only 10 customers here. So if you add a new customer here, MySQL will assign 11 to the new customer. Okay? And finally, here we have another column that specifies the default value for each column. For example, for our birth date and phone columns, the default values are null. So if we don't supply a value, MySQL will use the null values for these columns. Similarly, we have another default value for the points column. So if we don't supply the points for a customer, MySQL will use 0. Now, we have a few other columns here which are not important at this stage. You will learn about them later in the course. So now that you understand the attributes of each column in this table, let's go ahead and insert data into this table. In this tutorial, you're going to learn how to insert a row into a table. For that, we're going to use the insert into statement. Where are we going to insert this row? Into the customers table. So we type out the name of the table here, followed by the values clause. And here in parentheses, we supply the values for every column in this table. So back to our table definition, these are all the columns. First, we need to supply a value for the customer ID column. However, in this column, the auto increment attribute is enabled. And as I told you before, if we don't supply a value, MySQL will generate a unique value for us. So we can go back to our statement and either assign an explicit value or use default to let MySQL take care of generating this value. And this is the preferred approach. Because if you use an explicit value like 200, it is possible that you might have another customer with the same ID. So when you execute this statement, you're going to get an error because you cannot have duplicate values in this column. Every value should be unique. So here we're going to use the default keyword to let MySQL generate a unique value for the customer ID. Now after that, we need to supply a value for the first name and last name columns. So let's say John Smith. Note that I have enclosed these values with quotes because as I told you before, in SQL, we should always enclose string and date values with quotes, either single or double quotes, okay? Now, what else? Back to our customers table. After the last name, we have the birth date. However, As you can see, this column is optional because this checkbox is not checked. So here we can use null or an explicit value. Null means the absence of a value. So back to our statement, we can type out a birth date like 1990, January 1st, or we could use the null keyword to leave out this value. Now in this demo, I'm going to use a valid date. Now to make this code cleaner and more readable, I'm going to break it up into multiple lines. That's better. Now back to our table. Next we have phone, and phone is also optional because this checkbox is not checked, and null is the default value for this column. So here we can explicitly pass null or use the default keyword and let MySQL put null into this column. It's exactly the same. So back to our statement, we can pass null or default. Both these keywords will have the same result. In this case, I'm going to use the null keyword. All right, let's have one more look at our table. Next, we have 4 more columns that are required. So address, city, state, and points. And note that points has the default value of 0. So we can either use an explicit value like 200 or use the default keyword and let MySQL generate 0. So back to our statement. Let's type out an address. It doesn't really matter. Followed by a city and a state, let's say California. And finally, points. Again, we can use an explicit value or default. So this is how we can insert a row into a table. However, in this example, we are only supplying values for first name, last name, birth date, and these address fields. So we're leaving out the phone number, the customer ID, and the points. So there's another way to write this statement. Let me show you. So after the table name, we can optionally supply the list of columns that we want to insert values into. In this case, first name, last name, birth date. Now, once again, I'm going to break up this statement into multiple lines. So 3 more columns, address, city, and state. So these are the 6 columns that we're going to supply values for. With this change, we don't have to use these default or null values. We only supply values for these columns. So I'm going to remove default from here, then null, and finally this last default keyword. So these 6 values that we supplied here are used for these 6 columns. Now with this change, we can also reorder the columns. We don't have to list them in the same order that they are defined in the customer's table. For example, we can put the last name first, and then obviously we should also swap the order of these values, so we can list them in any orders. Now let's execute this statement. Now if you look at the output window, down the bottom, you should see the statement followed by 1 rows affected. Unfortunately, I cannot resize this window to show you this message, but if you look down below, you can see that 1 record was affected, which basically means 1 record was inserted into this table. Now let's look at the data in the customer's table. So the last row is the one that we inserted. You can see that MySQL automatically generated the value 11. This is the effect of auto increment attribute. So it takes the value of the last row and increments it by 1. So here we have the first name, last name, the birth date. We didn't supply a value for the phone attribute, so that's why we have null here. We also have address, city, state, and the default value of 0 for the points. In this tutorial, you're going to learn how to insert multiple rows in one go. For this demo, we're going to use this shippers table. Let's have a quick look at the table definition. So here we have 2 columns, shipper ID and name. Shipper ID is a primary key. It's not nullable, and it's an auto-incremented column. So we're going to let MySQL generate values for this column. Easy. We only need to supply a value for the name column. So back to our query editor window, we type out insert into shippers. In parentheses, we specify the name of the columns we want to insert values into. In this case, name, followed by the values clause. Here we add a pair of parentheses with a value like shipper1. Now, to insert multiple rows, all you have to do is to add a comma followed by another pair of parentheses. So shipper2, and one more time, comma, parentheses, shipper3. This is how you can insert multiple rows in one go. Now let's execute this statement. All right. And then inspect the data in the shippers table. There you go. So initially we had only 5 shippers, and here are the 3 new shippers that we inserted. Note that MySQL automatically generated the values for the shipper ID column. So we have 6, 7, and 8. All right, here's your exercise for this tutorial. Write a statement to insert 3 rows in the products table. That's pretty easy. You can knock it out in a minute. So here's our products table. We only have 4 columns. We're going to leave out the first column because it's an auto-incremented column. So we only have to supply values for name, quantity, and unit price. Back to our query editor window. Let's insert into products. The columns are name, quantity in stock, and unit price. And the values are going to be, let's say, product 1, stock is going to be 10, and the unit price is going to be 1.95. Now I'm going to select these values, copy, comma, paste it like this, change the values accordingly, and finally the last row, product 3. There you go. Let's execute this statement. All right. And then verify the result. So in the products table, now we should have 3 new records. Now the IDs you see here are 15, 16, and 17, because before recording this video, I actually inserted a few records in this table and then deleted them. So I had product IDs 11, 12, 13, and 14. Now, even though they're actually deleted from this table, MySQL remembers their IDs. So instead of incrementing 10 by 11, it incremented 14, which was the last record from before, and that's why it generated 15. On your computer, the IDs are going to be 11, 12, and 13. So far, you have only learned how to insert data into a single table. In this tutorial, I'm going to show you how to insert data into multiple tables. Here's a really good example. Look at the orders table. What columns do we have here? We have the order ID, we have the customer ID, so we know who has placed this order, we know the date of the order, we know the status, comments, as well as shipping information. But the actual items for this order are not in this table. They are in the order items table. So in this table, we have 4 columns. We have the order ID, so we know what order this item is for. We have the product ID, so we know what product has been ordered, at what quantity, and what price. So an actual order can have 1 or more order items. This is what we call a parent-child relationship. So in this relationship, the orders table is the parent and the order items table is a child. So one row in the orders table can have 1 or more children inside the order items table. Now in this tutorial, I'm going to show you how to insert an order and all its items. So you will learn how to insert data into multiple tables. All right, back to our query editor window. First, we need to insert the order. So insert into, let me close the navigator panel. All right, we want to insert a record into the orders table. Now, what columns do we have here? So we have these columns, but only the first 4 are required. And actually the first one, we don't want to worry about that because that's an auto increment column. So we only want to supply values for customer ID, order date, and status. So back to our query, we specified those columns here, customer ID, order date, and status. Now let's supply the values. In the customer ID column, we need to add a valid customer ID. So let's have a quick look at our customers table. There you go. In this table, we have 11 records. So these are the valid customer IDs. Now back to our query, let's use 1 for customer ID. And then 2019, January the 2nd for the order date, and 1 for the order status. Once again, in this column, we need to insert a valid order status ID. If we don't supply a valid ID, MySQL is going to yell at us. So we insert an order here. Now we need to insert the items. Now back to our order items table. In this table, we have this order ID column. So here's the tricky part. As soon as we insert an order, MySQL is going to generate an ID for our new order. Now we need to be able to access that ID in order to insert the items in this table. How can we do that? Well, back to our query editor window. In MySQL, we have a bunch of built-in functions, and a function is basically a piece of code that we can reuse. Just like the functions or features in your TV. Every TV comes with a bunch of built-in functions like power on, power off, change the volume, change the channel, and so on. So MySQL and other database engines come with a bunch of built-in functions that we can use in our programs. One of these functions is last insert ID. We can call or execute this function by adding parentheses here, and this will return the ID that MySQL generates when we insert a new row. So before going any further, let's just select this and make sure we get the right result. Now we have a syntax error here because we didn't terminate the first statement with a semicolon. All right. Now let's execute this query. All right. So the ID of the new order is 12. Let's verify that. So back to the orders table. Let's look at the data. On my machine, I have 12 records here. I actually created one just before recording this video. So on your machine, you're going to have 11 orders. Now back to our query window. Now that we know how to get the ID of the newly inserted record, we can use that ID to insert the child records. So we're going to write another insert statement, insert into order items. Let's have another look at the columns in this table. So we have 4 columns and all of them are required. So there is really no need to specify the column names in our insert statement. We simply supply values for order ID, product ID, quantity, and unit price. So here in the values clause, we add parentheses. What is our order ID? That is the value returned from calling this function. So I'm going to cut this from here and put it here. Next, we need to supply a valid product ID. Let's say product 1. Quantity, let's say 1. And the unit price, $2.95. Now let's delete this select. We don't really need it anymore. And let's add another set of values. So once again, we're going to call last insert ID to get the ID of the new order. We're going to change the product to product number 2 and at a different price. That's it. Now let's execute these statements and see what we get. All right. So back to our orders table. Let's refresh the records here. All right. So we have a new order, order number 13. Beautiful. Now let's look at the order items table. Here's the order items. Let's open the table. So we should have 2 items for order number 13. Beautiful. So this is how you insert hierarchical data in MySQL. In this tutorial, I'm going to show you how to copy data from one table to another. For example, in our orders table, currently we have about a dozen records. Now let's say we want to create a copy of this table called orders archived, and we want to insert every row that we have in this table into that new table. If we have 10 orders, we don't want to code an insert statement with 10 set of values. That is very time consuming. So I'm going to show you a powerful technique to quickly copy data from one table to another. First, we need to create this new table, orders archived. For that, we're going to use the create table as statement. So create table orders archived as. Now, right after that, we write a select statement to get everything from the orders table. Now, let's see what happens when we execute this query. There you go. So back in the navigator panel, we have to refresh this view by clicking on this icon over here. Now we have a new table, orders archived. Let's look at the data. So you can see all the orders are here, and we have the exact same columns as the orders table. However, if you open this table in the design mode, you can see that in this table, we don't have a primary key. So the order ID column is not marked as a primary key. And also it's not marked as an auto increment column. So when we create a table using this technique, MySQL will ignore these attributes. And that means if you want to explicitly insert a record into this new table, we have to supply a value for order ID because this column is no longer an auto increment column. Okay. So using create table as statement, you can quickly create a copy of a table. Now, we refer to this select statement as a subquery. So a subquery is a select statement that is part of another SQL statement. Now we can also use a subquery in an insert statement, and that's a very powerful technique. It allows us to do really cool things. Let me show you. So first, let's right-click the orders archive table and click on truncate table because we want to delete all the data in this table. All right, it's asking for confirmation. Let's truncate the table. So now back to this table. Let's refresh the table. We don't have any records here, okay? Now back to our query editor. Let's say we want to copy only a subset of records from the orders table into this table, like all the orders placed before 2019. So first, let's select everything from the orders table where order date is less than 2019, January 1st. So these are all the orders number 2 to 10. Beautiful. Now we want to copy these orders into the orders archive table. So we can use this select statement as a subquery in an insert statement. We write insert into orders archive. Now we don't need to supply the column names because we're going to supply values for every column that we have in this query. So we did that, and this is an example of using a select statement as a subquery in an insert statement. Let's execute this. All right, now back to the table. Let's refresh the records. We only have the orders placed before 2019. All right, here's a really cool exercise for you. Back to our SQL invoicing database, look at the invoices table. So in this table, we have these columns: invoice ID, number, client ID, which is associated or related to the client ID column in the clients table, followed by a few other columns. Now, let's say we want to create a copy of the records in this table and put them in a new table called invoices archive. However, in that table, instead of the client ID column, we want to have the client name column. So you need to join this table with the clients table and then use that query as a subquery in a create table statement. Also, to make the exercise more interesting, I want you to copy only the invoices that do have a payment. So if you look over here, this payment date column determines if a payment has been made towards this invoice or not. So select only the invoices that do have a payment date. It's a really good exercise. Spend 2 to 3 minutes on this and then come back, continue watching. All right, first I'm going to use the SQL invoicing database. Now let's select everything from the invoices table and join it with the clients table. Here I'm going to use the using statement to simplify my join. What column are we going to use for joining? The client ID column. Let's execute this query up to this point. All right. So first we see the client ID column that is used for joining these tables. After that, we have the columns from the invoices table, like invoice ID, number, and so on, followed by the columns from the clients table, like name, address, and so on. Obviously, we don't want all of these columns. We only need the columns from the invoices table, but we should replace the client ID column with the client name column. So let's have a quick look at the design of the invoices table. Here we have invoices ID, number, client ID. We want to replace this column with the client name. So back to our query. I'm going to pick invoice ID, number, and then client.name. Let's rename it to client. What other columns do we have here? We have invoice total and payment total. So let's add those as well. Invoice total as well as payment total. We also have 3 columns for dates: invoice date, due date, and payment date. So let me close the navigator panel. Invoice date, payment date, and due date. Now, technically, because these columns only exist in the invoices table, we don't have to prefix them with a table alias. So we could simplify the code like this. However, I personally prefer to prefix them because that gives me a more clear picture of how I'm joining these tables. It's just a personal preference. Another developer might disagree, and that's perfectly fine. So whatever you prefer, that's perfectly fine. Let's execute the query and make sure we get the right result. So we have the invoice ID, number, client, beautiful, followed by these other columns. Now we want to filter the result and return only the invoices that do have a payment. So we can either return records that have a payment date or the records that have a payment total of greater than 0. Those are perfectly fine. So back to our query. Down the bottom, let's add a where clause where payment date is not null. That's better. Let's execute the query one more time. Now we get only this handful of invoices. Beautiful. Finally, let's use our query as a subquery in a create table as statement. So right before select, we type create table, invoices archived as, there you go. Let's execute the query. Beautiful. Now back to the navigator panel. Let's refresh the view. So here's our new table, invoices archived. Let's look at the data. There you go. We only have the invoices paid, and here's the name of the client for each invoice. Beautiful. Now just note that if you execute this query one more time, you're going to get an error because we already have a table called invoices archived. Later in the course, I'll show you how to drop tables. That's pretty easy. But for now, you can just right-click and go to drop table and then confirm. All right, and then you can run the query one more time. In this tutorial, I'm going to show you how to update data in SQL. So back to our invoices table, look at the first record here. The payment total for this record is 0, and obviously there is no payment date. Now let's imagine that there was a problem in the system that recorded this information. Let's say the client paid $10 for this invoice. So we should update this record in this table. That is very easy. Back to our query editor window, we use the update statement to update one or more records in a table. What table? In this case, invoices. Next, we add the set clause, and this is where we specify the new value for one or more columns. In this case, we want to update payment total. Let's set it to $10. We should also update payment date. So we use a comma to add more columns. We set this to a date value, let's say 2019, March 1st. And then we type out a condition. With this condition, we identified the record or the records that need to be updated. In this case, we want to update the invoice number 1. So back to our query, we type out invoice ID equal to 1. Let's execute this. Beautiful. Now back to our table. Let's refresh the data by clicking on this icon. All right, you can see payment total is updated to 10, and we also have a payment date. Beautiful. Now let's say we actually updated the wrong record. Maybe we should have updated invoice number 3. So we should update this table one more time and restore the original values in these columns. Back to our query, we can set the payment total to 0 and the payment date to null. So we can use the null keyword to insert the null value in a column that accepts null values. Now back to the navigator panel, let's open this table in the design mode. You can see that the payment total column has the default value of 0 and the payment date column has the default value of null. So back in our query, we can also set payment total to default, and MySQL will use the default value for this column, which is in this case 0. So let's execute this statement one more time. Beautiful. Now back to the table, let's refresh the data. So payment total is set to 0 and payment date is null. Beautiful. Now let's go ahead and update the third payment. Look at the invoice total. That is $147. For this example, let's imagine that the client made 50% of the total amount on the due date. So back to our query editor window, instead of using a literal value here like $70, we can write an expression. We want to calculate 50% of invoice total. So invoice total times 0.5. Now let me break this code into multiple lines so we can see clearly. Now we should set the payment date. As I told you, this client made the payment on the due date. So we can set this to due date. Whatever value we have in this column will be used to set the payment date. And obviously, we need to update the invoice ID, number 3. Now, back in the table, let's refresh the data. All right, look, payment total is updated, and it's set to almost 50% of the invoice total. However, this number is truncated, so we don't have the digits after the decimal point. Don't worry about it for now. We'll come back to this when we talk about data types later in the course. Also, you can see that payment date is set to the same value we have in the due date column. In the last tutorial, you learned how to update a single record using the update statement. Now, if you want to update multiple records, the syntax is exactly the same, but the condition that you type out here has to be more general. For example, back to the invoices table, you can see that we have multiple invoices for client number 3. We can write a statement to update all the invoices for this client. So back to our query editor window, we change our condition to where client ID equals to 3. However, if you execute this statement with MySQL workbench, which is the software we've been using in this course, you're going to get an error because by default, MySQL workbench runs in the safe update mode. So it allows you to update only a single record. You're not going to have this problem if you use another client for MySQL or if you write this statement in your application code. This is only specific to MySQL workbench. Now let me show you how to get around this. So on the top, we go to MySQL workbench menu and then preferences. On this dialog box on the left side, click on SQL editor. And then down the bottom, untick this checkbox, save updates. So this prevents you from accidentally updating or deleting a bunch of records in a table. So let's go ahead with this. Now we need to reconnect to this instance of MySQL. So let's copy all the code here and close this local instance window. All right. Now on the home page, double click this connection to reconnect. There you go. And then paste all that SQL code. Now let's execute this. Beautiful. All the invoices for client number 3 were updated. Here we can also use the in operator. Let's say we want to update all the invoices for clients number 3 and number 4. So all the operators you learn to use in the where clause also apply here. Now technically this where clause is optional. So if you want to update all the records in a table, you simply leave it out. All right, here's your exercise for this tutorial. Back to our SQL Store database, write a SQL statement to give any customers born before 1990 50 extra points. All right, first I'm going to use SQL Store, then write an update statement to update the customers table, set the points to points plus 50. So here we're using an expression to update the points column for anyone born before 1990. So where birth date is less than 1990, January 1st. All right, let's execute this query. All right, now let's open up the customers table one more time. So anyone who was born before 1990 now has an extra 50 points. In this tutorial, you're going to learn how to use subqueries in an update statement. That's extremely powerful. So we're going to continue with the example from the last tutorial, but we're going to make it more interesting. Here we're updating all the invoices for client number 3. But what if we don't have the ID of a client? We only have the name. For example, imagine you have an application, and in that application, the user types in the name of the client. So first, we should find the ID for that client, and then use that ID to update all their invoices. How do we do that? Well, let's have a quick look at our client table. So here we have this client, MyWorks. Let's say we have the name. We want to find the ID. So back to our query editor window. After this update statement, I'm going to write a select statement to select the client ID column from the client's table where name equals MyWorks. Now here we have a syntax error because we didn't terminate the last statement with a semicolon, but don't worry about that. We're going to get back to that in a second. Let's just select these few lines and execute this query. The ID of this client is 2. Beautiful. Now, we can use this select statement as a subquery in an update statement. So as I told you before, a subquery is a select statement that is within another SQL statement. So instead of hard coding 3 here, we're going to use this select statement as a subquery, but we need to put it in parentheses. So MySQL will execute this query first. It will return the client ID and then use it in this condition. So for clarity, let's remove the line break and indent these few lines. So this is the end result. Now we execute this query, and this updated all the invoices for this client. Now, what if this query returns multiple clients? For example, back to the clients table, let's imagine we want to update the invoices for all clients located in New York or California. So we need to update our subquery like this, where state in California and New York. Now, before executing the entire statement, let's just select our subquery and execute it to see what we get. So we get 2 client IDs, 1 and 3. Beautiful. Now, because this query, this subquery, returns multiple records, we cannot use an equal sign here anymore. So we need to replace this with the in operator. And now this statement updates the invoices for all clients located in these 2 states. Let's execute it. Beautiful. Everything worked. So as a best practice, before executing your update statement, run your query to see what records you're going to update, so you don't accidentally update the records that shouldn't be updated. Now here we have a subquery, but even if it didn't have a subquery, we could still query the records that we're going to update. Let me show you. So let's imagine we're going to update all the invoices where payment date is null. Before executing this entire update statement, I would run a query like this. Select star from invoices where payment date is null. Now let's execute this query. These are the 2 records that don't have a payment date. So once we're confident that we're updating the right records, then we come back here and get rid of this select statement and just attach the where clause to our update statement. All right, here's your exercise for this tutorial. Back to our SQL Store database, look at the orders table. As you can see, some of our orders don't have a comment. I want you to write a SQL statement to update the comments for orders for customers who have more than 3,000 points. So customers who have more than 3,000 points, we regard them as gold customers. Find their orders. If they have placed an order, update the comments column and set it to gold customer. That's a really good exercise. All right, first we need to find the gold customers. So select everything from the customers table where points is greater than 3,000. And by the way, because the current database is SQL invoicing, we either have to type out a use statement on the top or double click this database before executing this query. So there you go. We have 3 gold customers. Now we need to get the ID of these customers to use them in an update statement. So we only select customer ID here, and then use this select statement as a subquery and an update statement. So update orders, set comments to gold customer, where customer ID, because we're dealing with multiple customer IDs, we need to use the in operator. And then to use this as a subquery, we need to enclose it in parentheses. That's it. Let's indent the code. That's better. So here's the final solution. So you have learned how to insert and update data. In this lecture, we're going to finish this section by learning how to delete data. That is very easy. We use the delete from statement to delete records from a table. Let's say the invoices table. Now, optionally, we can add a search condition to identify the records we want to delete. If you don't write this where clause, with this statement, we'll delete all the records in this table. And obviously, that's very dangerous. So be very careful when executing this statement. Now here, let's say we want to delete the invoice with the ID 1. So where invoice ID equals to 1. Now here we can also use subqueries. Let's say we want to delete all the invoices for the client called MyWorks. First, let's find this client. So select everything from the clients table where name equals to MyWorks. Let's execute the second query. So here's our client. Now we can get this client ID and use it in our search condition. So where client ID equals to, this is where we add our subquery. There you go. Just like before. Beautiful. So this is how we can delete data in SQL. All right, we're done with this section. But before going to the next section, I want you to restore all these databases to their original state. Because in this section, we added some data, we updated some data, we deleted some records. So if you don't restore these databases, you might see different results going forward. So restoring these databases is pretty easy. Here in MySQL Workbench, on the top, go to the File menu and open SQL script. Then navigate to the directory where you stored the SQL scripts for this course. In case you lost that directory, go back to the first section. We have a lecture for downloading the supplementary materials. So in this directory, open create databases.sql. Now execute this script to recreate all of our databases. All right, beautiful. Now let's open up the navigator panel. You can see the databases disappeared from here. Simply click on this refresh icon. Beautiful. All right, we're done with this section. I will see you in the next section.